Hello, this is John Greiner with Basin Safety Training and Consulting. This month, April 2020, we're covering a special set of topics for everybody that's in our training videos. A short little segment on wash-in, wash-out training, preventing people from illnesses such as COVID-19 and the coronavirus and other types of illnesses that can get you sick in the workplace or at home. So these are procedures for health and safety during any type of airborne illness outbreak. So obviously the main purpose is illness prevention. We want to provide safeguards against potential spread of infection, ensure excellent hygiene, protect the public from potentially carrying illness forward. Even if you are immune to the coronavirus, you can carry and spread it to somebody else. So that's going to hopefully flatten the curve of any viral spread, as you may have seen charts in the news media, and also continue critical business operations while mitigating risk. Us in the oil and gas industry, we're considered essential workers, meaning that we must continue working in order to keep the country moving. So that means that we are at additional risk of being infected or carrying illness forward. So we want to make sure that everything we do prevents that from occurring. So first step in that is obviously prior to home departure. So one thing we want to do is make sure we're wearing clothes that are clean every day. Bathing and making sure that our bodies are clean, utilizing antibacterial soap or certified hand sanitizer. We do not recommend home remedies, meaning I bought some concoction online, mix it up, I'm a chemist, and boom, it's going to kill all the bacteria. Are you sure? Has it been tested? Does it actually work? Whereas you buy the Germ-X, even though that's a little bit difficult to get a hold of right now. We know that that's been tested, and the ingredients actually do kill germs. Also, packing all food inside of sealed bags and lunch boxes, utilizing mouthwash as much as possible, and checking your temperature. If you check your temperature in the morning and it's above 90 degrees Fahrenheit, you should not be leaving home, especially if 99 degrees. You should not be leaving home. That's just a time to stay at home. Even if it's not, the coronavirus, we want to prevent anybody from getting sick at this time for any reason. So travel is a big deal. We've all seen memes online of people, quote, protecting themselves while itching their their backside while filling up at the fuel station. So that's one big one, obviously, where many people are going to touch something that you're touching, any surface or equipment. You want to make sure that you're protected. So using gloves when filling up at petrol stations, and they don't need to be like latex gloves. They can be leather gloves or other types of gloves that protect you. Do not enter stations unless necessary. Obviously, you want to limit your interaction with the public. If you do have to enter, continue to wear gloves. This might be a little bit weird wearing leather gloves, but hey, whatever, it's going to protect you. Restaurant drive-thrus as well. When taking food or giving food, make sure that the guy that you're wearing gloves. Don't be touching those guys because they're touching a lot of other people. And then also, after eating in the workplace or in the truck, wash your hands. Use your antibacterial soap or sanitizer. Make sure that everything is clean. So in the workspace, we got a couple different types of workspace. People that are going to watch this video, we want to make sure that we wash our hands before entering the workspace. If you're working in a shop, before you enter the shop, avoid shaking hands. A lot of us have probably gotten used to the fist bump or the elbow bump by now. And then using Lysol wipes to wipe down tools or equipment after handling if you're not wearing gloves. Working in the field, avoid handshaking again, cleaning all equipment after handling, and hand tools before putting in the toolbox. You want to make sure that anything that we're touching that other people can touch is completely sanitized before and after use. And then if you do make contact with personnel, this is kind of where the wash in, wash out, wash in prior to working and wash out before leaving work or before completing a task. So workspaces, PPE. So PPE in the shop, we want to make sure that we're utilizing gloves while working with equipment. And obviously some jobs and tasks require different types of gloves. Check your PPE policy and program to determine what types of glove. And then PPE in the field, same thing. Check your field safety handbook or health and safety manual, and it should give you directions for what PPE, specifically gloves. So workspace hygiene, if you're working in an office, we want to make sure that, once again, prior to going to the office, we wash our hands. Avoid handshaking as well, fist bump, elbow tap, and then use Lysol wipes on computers, printers, shared equipment, or electronic wipes, probably a better option. Dining at work, if you have to eat at work, once again, wash your hands, keep your stuff sealed, and then wash hands after eating as well. Basically, we want to prevent any germs from moving from one space to another. Public spaces. So we already talked about gas stations, but even if it's a grocery store, a liquor store, any place you're going where other people are, we want to make sure that we avoid entering them if we can. Is this a delivery pickup option that I have? Can I send my kid? I don't care if he gets sick. No, I'm just kidding. But you do want to prevent yourself from going into these areas. And then utilize the pickup services and ensure hands are washed prior to entering public spaces. And then once you leave, you want to sanitize as well. PPE in public spaces, not a super popular thing, but definitely something to consider. Wearing the gloves. I don't, walk around in a hazmat suit myself. You could do that. I know that there's technologies being worked on right now that are a little bit more easy and user-friendly than, a Tyvek suit. But you can wear respiratory equipment such as masks. You see a lot of people doing that. There's a reason that GM, Ford, Dyson, JGB, all these companies are developing ventilators now. They're refurbing ventilators. The reason for that is obviously clean breathing space. And then lastly, removing gloves prior to entering vehicle, utilizing professional glove removal process. If you're curious what that looks like, you reach in and you pinch the inside palm of one hand, pull the glove off, and then reach to the very tip of the other glove around the wrist, and then pull it over that other glove and then toss it. That's the professional way to do it. So our safety topic for this month is isolation of hazardous energy. That's 29 CFR 1910-147, understanding the requirements of lockout tagout programs. I'm not going to push for anyone to remember 29 CFR 1910-147. No worries about that. Your biggest concern is, are you knowledgeable about how to lock and tag out equipment before you utilize it? So the objectives for today. We're going to be talking about the Lockout Tagout standard, also understanding different types of hazardous energy. Really the big picture here for Lockout Tagout is controlling uncontrolled hazardous energy. And so when we look at that, it's, you could really call it that, the hazardous energy control procedures. Demonstrating an understanding of lockout devices and tag devices, understanding requirements for procedures, and lastly, understanding your company's lockout tagout program. So the purpose of lockout tagout is obviously, as I mentioned, to control uncontrolled hazardous energy, and specifically people being exposed to that uncontrolled hazardous energy. And it doesn't have to be, we typically think of electrical or even fluid, locking out fluid, locking out equipment from moving, but it can be something as simple as, a guy behind a door painting or doing some trim work and not locking the doors. So if somebody wants to come through that door, they open it up, knock them off the ladder. We have uncontrolled hazardous energy, door into a ladder, guy falls down, ends up on Bach and fail of the day, and everybody, hopefully has a good sense of humor about it. But our goal here is to prevent, obviously, any type of uncontrolled hazardous energy, whether conventional or unconventional. And this is accomplished by the use of locks, tags, or other barriers to prevent that from occurring. So the standard itself, the OSHA 1910 standard, says this. It requires that employers develop a written plan for dealing with the isolation of hazardous energy. And that's for machines and equipment where unexpected startup could occur or the release of stored energy could injure employees. That includes kinetic energy, as I mentioned before, gravity, mechanical, electrical, steam, etc. And we'll go through a few of those here in a moment. So employers have to provide the devices, give the tags, give procedures, which is very commonly not available to employees, and lastly, provide the training for them, depending on what type of work that they do. So, for example, if you were to hire a brand new employee who's going to be working on this piece of equipment, which is a pressurized fluid system, you wouldn't want to say, "Hey, man, we need to change a spring out, in this part of that equipment. Here's a wrench. Here's a couple locks. You just go figure it out." You would want to have that guy really be well versed and trained in that process. So lockout tagout isn't required in certain instances, however. So there are exceptions to the rule. When activities are performed during routine production processes, meaning step 1 to step 5, you have to have the equipment open to do the work, then that's not a lockout tagout situation. If obviously hazardous energy does not exist, kind of goes without saying, but we'll drop it in there. Or if you're working on a device that's controlled by a cord. So if an individual is you can plug that equipment in and unplug it, then that's the best way to release that stored energy. However, or to prevent energy from happening. However, it can hold stored energy and release it, with the example of the old tube style TV sets, if you guys remember those. When I was a kid, they were still around. And they had a capacitor inside that essentially holds power. It was the design. So technicians working on televisions back when they used to do that, they would open up the back of the TV, inspect it to work, and they would actually come into contact with that capacitor and be electrocuted, sometimes fatally electrocuted if there was enough stored up. So things like that, even if something is unplugged, it can store a certain amount of energy. And lastly, hot tap operations. So for my pipeline guys, people that are working around, essentially tying into a line that's existing. It doesn't always have to happen, but in certain instances, it's the only way to get the work done. Those lockout tagout procedures aren't required. As I mentioned, we're going to cover some types of hazardous energy. Electrical is, like as I mentioned, one that a lot of people think of. Stored mechanical, moving machinery, steam, springs, gravity, kinetics, and pressurized fluids. In all these instances, obviously, we want to have control over the movement of the parts, the equipment, the fluid. And so really, that's the goal here, is to have ultimate control, absolute control through planning and strategies, just making sure. And even if it's a small spill, we want to prevent those as well. So type of equipment, we're going to go through a few different, short list here. Accumulators, saws, pumps, for example, production equipment, fluid systems, motors, all these different types of equipment would require some sort of lock if you're going to be doing work on them downstream. So, for example, here I have a picture of a dart seal, which is not a true lockout tagout device, but it's another type of a lock that essentially deals with custody of fluids. So there's all kinds of different types of locks, and this one's kind of a lock and a tag. So a lot of times when I give this training, people ask, what do you do when equipment cannot be isolated or locked out? So that does happen from time to time, where it doesn't have a true lock, a hole for a lock, or a valve that closes. So what do you do? Well, there's a lot of different strategies that you can implement. This, for example, the photo here is a picture of a cable style lock, where you essentially run a cable around a piece of equipment, through a wheel, through multiple locks if there's multiple areas to put a lock through, so you don't have to have 15 locks for something small. You can actually run this cable through, and they come in all different lengths, and then you just lock the cable clamp down. So you can also remove critical components. So, for example, if you are concerned that someone's going to start up an excavator while you're working underneath it, and there's multiple keys that work for that excavator, so just taking the key out doesn't necessarily prevent its startup. Remove the battery, remove the spark plug mechanism, remove anything that's going to provide the ability for that equipment to start. Chains and cables, as I mentioned, and also barriers and enclosures. I mean, if you're going to be working on a piece of equipment and it can be moved inside of a room that you can lock, or even if you can lock up the whole shop and put a sign, hey, I'm working on this, those can also be implemented when pieces of equipment don't necessarily have your typical, quote, lockout tagout capabilities. So I would say 99.99% of the time you can do something to prevent physically, and not just a sign. You don't just want to tape a sign on something and say, please don't touch. As we know, human beings are not always apt to read, number one, and two, follow directions. So if your life's at risk working on a piece of equipment where somebody could inadvertently lift that piece of equipment, you definitely want to make sure that you're protected. So some fundamental keys to keep an employee safe in energy isolation. Each employee, first of all, one of the main components, they need to have their own lock. Tag, I'm a little bit looser on that. You could have multiple locks with one tag. Really, the tag needs to be designed or used in a way that gives people information. So if you have 15 tags, I mean, that's a little bit overwhelming. But if you have one where it has the main supervisor or authorized personnel contact information, and we'll get into this a little bit later, as well as, why the equipment's down and who to call, if they have any questions. So the reason they only have one lock is in one key to that lock, or they only have control of that key, is you don't want multiple people being able to lock and unlock locks. It's really this is your safety device for you personally. So you don't want other people to have control or access to that. So the lock that they apply will only have one key, and it will be in their possession. And lastly, we want to make sure the energy of whatever it is that we're working on cannot be released accidentally or purposefully until all locks have been removed. And this is a step in the lockout tagout process. It's typically not followed. Guys will, they'll shut down equipment, they'll release stored energy, they'll lock it out, and they'll go to work without testing it. And, hitting that power switch, trying to turn the valve, really giving it, hey, if somebody was really trying to open this, would this lock actually work? And sometimes, especially to use valves as an example, ball valves specifically, those balls in there, they can have a little bit of give with your handle. So if you're moving that handle, it may allow fluid pass. And reminded of an instance, I met a gentleman on an airplane once flying to Denver, Colorado. And on the plane, we had a nice chat, and he was telling me about his line of work. He was in ammonia processing facilities for freeze-drying potatoes, typically sold to places in Idaho for McDonald's, etc. And they use anhydrous ammonia to super cool these potatoes to keep them fresh longer. And so he was sharing kind of with me an incident that occurred where an individual was downstream and he did not put his lock upstream, and he thought everyone was gone for the day and he thought he was safe, he was good to go. But there was a tour scheduled, and a couple guys were walking through, and a guy who does the tour knows about the facility, didn't know the gentleman was working downstream, and said, hey, this should not be closed right here. Goes ahead and opens the valve. Well, the gentleman working downstream was welding on a pipe, so he's right up next to that pipe. And fortunately, he had turned his arc off. He wasn't welding at the moment, but that ammonia flew through the air, went into his lung, and froze his lung, created all kinds of problems. The guy will never breathe normal for the rest of his life, all because he didn't lock out a valve that somebody could have, that somebody was able to open. So these stories, and as a lot of you know, OSHA regulations are not written in maybes and ideas. They're written in blood. So individuals, the reason for these standards, even as far back as 1970, they're there because of instances of bad things happening. So don't think you're special or unique. And also know, if this kind of concerns you, that there are plenty of actual strategic ways to prevent release of stored energy of any sort of type, whether it's electrical or flammable, or in this case, cold freezes you up. So we want to make sure that either by accident or on purpose, a release of stored energy is not possible. So now we're going to move into isolation devices a little bit, different types. So you have multi-lock hasps, you have valve covers, chains, blocks, ball valve covers, piping blanks. And here we've got an example of a few. The first picture on the upper left hand is obviously a tag and a lock, and that lock is designed to be able to lock multiple locks. So if you got 6 people working, in this case, on an electrical unit there, it only has room for one lock on the actual knob. So you put that through, and then 6 different people can lock out, and no one removes another person's lock, and you don't remove your lock until it's safe to do so. To the right, that's called a pancake or a blank, and essentially it prevents fluid from moving upstream to downstream by providing a solid faceplate. The third one there on the bottom left, that's essentially a ball valve triangle lock, so you can put multiple locks on it, and it prevents that handle from being able to move down. Now you'd think, and I'm kind of this mindset, if I walk up to a valve, even if there's not a lock on it, and there's a triangle on it like that, I'm like, maybe I shouldn't open this. But not everybody thinks that way. So we're essentially kind of stupid-proofing things for our own good. OSHA probably wouldn't call this stupid-proofing, energy equipment for your own good, but you could reword it that way for the basic people like myself out there. But on the bottom right there, we have essentially a cord cover, right? So that the cover there swings shut. There's you line up the holes, lock it out, and no one can plug in that piece of equipment, even if they choose to. So the next slide, going to talk about guards as locks. So there's something called an interlocking guard. So lockout tagout device requirements. A few different basic things. They need to be durable, standardized, substantial, and identifiable. Essentially, they need to be able to stand in the weather, be legible in whatever language you're using it, and you can read why the equipment's locked out, who to call, and essentially what you're not supposed to do. In this case, do not operate a switch, a valve, etc. Can't just be a piece of paper taped to the side of a tank saying don't operate. It needs to be specifically tied to that lock, and once again, be durable. Now we're going to move into a little bit more specific information about the people involved in lockout tagout. So people such as yourself. So there's 3 different types of basic people that we cover in this training. The first is authorized employees. So if you're an authorized person, you probably already know it. Your job is to essentially apply the locks, know how to use the equipment, know how to maintain the equipment, and remove the lock when the work is done, as well as follow the proper procedures, whether it's a form you fill out or a document that you have to send in or a permit, whatever it is, you're aware of these things. So your job is obviously to control that site or that equipment that needs to get worked on. So typically, these individuals need to be trained specifically on each piece of equipment that they're supposed to be working on, and they cannot put their lock on a piece of equipment and have another guy work on it. That does happen. That's not OSHA, obviously, as we went before, it's not OSHA approved. The design is this individual puts his own lock before he goes to work. And if another person's going to work on it, that's fine. You have to figure out a way to have multiple locks. And there's another way to do it as well. You can have the authorized employee's lock on that piece of equipment and then a lockout tagout box with his key inside and other people's locks on the outside of that box. And I'm sure many people in this training have seen that. Essentially, it's a box with a lot of holes around the outside where the locks can fit. Typically red in color, doesn't have to be, just has to be designed so people can't easily access that key. So their responsibilities, if you're in this world, you already know. Your job is to place the tag with the lock, inform the affected employees about the lockout tagout operation, and that can be through email. Internally at Base and Safety, we use an app program called Slack where we can communicate. So if our compressor is down, which is usually what we have to lock out in the company, we just go ahead and send a message, hey, compressor's down, my lock's on it, nobody try to operate. And that's just an additional precaution. Doesn't always work. I wish it did, but that's the goal. And also ensure that the sources are isolated. Test the equipment after it's locked out to make sure it doesn't kick on. Repair as needed, and then remove the lockout tagout devices and restart/restore the equipment. So that's the first type of person, the authorized employee. The second type of employee is the affected employee. So the affected employees are employees that operate equipment. They don't typically perform service or maintenance or lockout tagout. So for example, in the instance of the compressor, this is a breathing air compressor, so we actually fill 6,000 pounds cylinders with breathing air to put out on location to protect people from H2S. So large four-stage compressor. We have lots of guys that use it and fill systems. One guy that fixes it if it goes wrong, including the contractor that sold us the equipment. So when anyone's working on it, they've got essentially the authorized guy is the only guy that's going to fix that equipment, but lots of people use it. So when it goes down, their job is obviously to communicate that to us in the company, and then also stay away from it when it's locked out, more or less, as well as following procedures and safety requirements. So the third type of person is the other worker, quote unquote. They may be in the area where the lockout tagout's performed or where maintenance is being done. They may work, next door or in the next, area. It's not letting me go back here. Oh, there we go. So essentially that's the other employee. Basically doesn't do anything with that piece of equipment at all. So this is a 6-7 step process, and 7 isn't actually a part of the process, so I put it in there, but and also to mess with your brain a little bit, make sure you're paying attention. So there's 6 basic steps to lockout tagout with a 7th. So you got that extra little bit there. Number 1, notify employees. As I mentioned, you can do that through an app base, send an email, make a phone call, over the intercom, however your company informs people of what's going on. Number 2, shut the equipment down. Brrr. Push the button, shut it down, turn the valve, hit the switch, whatever you got to do to shut it down. Number 3, isolate the energy. So this obviously, once again, that may be a valve that closes, that may be unplugging something, whatever it takes to remove the continuity from one area to the next of the energy. Isolate it. Number 4, attach the device, the lockout device, with the tag, of course. Number 5, release the stored energy. That means, for example, if there's any back pressure on the downstream side, go ahead and open that up. If you're pigging a line, for example, you'd go ahead and bleed off the pressure on the downside. And number 6, verify the lockout. So want to make sure that you test it out. So some people say LOTO, BATO, which is lockout, tag out, blank out, test out, blank out, bleed out, test out. I really like that. So there's different ways to look at this, but lockout, tag out, for the essence of what OSHA's asking, is the way we're going to look at it. And then lastly, after doing all that, you service and maintain. And I want you to note that there's 3 steps before you even get to attaching the lockout device. So it's not as simple as just putting a lock on something and going to town. There's 7 steps to this, of the whole process. And then lastly, you could add an 8th, which is removing the lockout tagout. But this is just pre-work. So this is the lockout tagout procedure. So group lockout tagout, I mentioned this before. This is an example of what it looks like. So each person has their own lock, their own key. And I want to note one more thing on this picture here. So as you'll notice, these 5 locks are all the same size and brand, but different colors. And they have the name tag. That's, good idea. Not required, but I think it's pretty smart. You can also use a Sharpie, whatever you want to do, just so you know whose lock is whose. Now, the thing about using different locks is OSHA absolutely allows that, but they have to have one unified characteristic, meaning they have to either all be the same brand and size, which these ones are, the same color, or the same size. So essentially, type. So as long as they have one of those unifying, they don't have to have all of them. It's not a bad idea to have those different areas. So for us, we use red locks across basin safety. We have big locks, we got small locks, we got cables, but they're all red. So we know those are basin safety's locks. So when another company comes in, we don't allow them to use red locks to lock out our equipment because that's our color. Figure it out, bro. Spray paint it blue. That way we know whose lock is whose by company when we're working on equipment. So that's just how we roll. So when you do that, obviously the intent here is to have multiple people locking equipment out. On the tag side of the house, once again, you want to look at locks and tags like salt and pepper. They just go together. Jam and peanut butter. They just belong together. So if you see a lock without a tag, something's wrong. And even if you're an other employee, quote unquote, it's your job to communicate that issue to someone, especially if you're affected. Definitely if you're authorized, you want to communicate that. And 99% of the time, you cannot use a tag for a lock. So there's going to be some times where that can happen. However, just remember that that's going to be so rare. And if it is the case, you would already know that because you've been trained so thoroughly that a tag is available and as a replacement for a lock, that there will be no question. So just to put that exception out there, it does exist, but obviously a tag does not provide the same exception as a lock, right? It's like putting leaving your keys in the truck overnight, leave it unlocked, and just put a little tag on there that says "Please don't steal." Oh yeah, that's a true protective device. No, that is just it's a administrative control, quote unquote, not an engineering control. And that's really the goal here, is to provide as many engineering fixes as we can. So what do you do if you have to remove a lock? It's a great question. You get asked it often. If you have to remove a lock, it's going to be very rare that occurs. One story that comes to mind is an individual was working for Neighbors Drilling. Some of you guys may be familiar with Neighbors. Maybe if you worked for Neighbors. Neighbors has a very, very stringent lockout tagout policy. So he locked out a pump and went on days off and forgot to take his lock off. Well, 3 days into his hitch or his off hitch, he gets a call. Hey, dude, we noticed that you left without taking your lock off. And he's like, oh yeah, man, dang it, I forgot. And they're like, okay, well, I'll tell you what, we're not taking your lock off, so you're going to have to fly back to Williston to take your lock off. And he hemmed and hawed and complained, and they're like, no, man, it's your own expense. You're going to have to fly back here. We're not starting this pump without you taking this lock off. And they lost days of drilling because this guy didn't take his lock or didn't remove his lock before he went on days off. In some instances, like in mines, they'll use something called dropping brass, which is a similar type of model where it's like a check-in, check-out type thing. They want to make sure that you are actually safe. That's the whole thing, that you're not going to be harmed. And a lock on a piece of equipment means that you are in harm's way, essentially is what it's saying. It's like, I'm in, if this piece of equipment started and my lock's still on there, I could be harmed. So it was his bad for not taking his lock off, and they made him fly back and take it off before they started the pump up. So just know that this is very serious. So, however, other companies aren't as stringent. There are documents you can fill out and a process you have to follow, but it needs to be very well documented why someone else's lock needs to be taken off, such as somebody going to the hospital, etc. So kind of getting to the last part of this as far as the written lockout tagout standard and your company policy. Here's a picture of our kind of process document for documenting lockout and tagout. So whenever we remove a lock or put a lock on, we want to document why we did it. So in this instance, you can see if you look real close there, we have equipment manufacturer, what task we're doing, where we're doing it in the facility, what type of energy we're locking out, and then on the left side, kind of a checkbox and a little description of what we're doing. So step 1, I turn the power off. Step 2, I unplug. Step 3, I wrap a chain around the blade. Step 4, try to turn the equipment on, make sure it doesn't move. Step 5, remove blade. Whatever the process is, you just want to write down each one. It's a little bit of a JSA, more specific to lockout tagout. And so that process is going to be written in your internal lockout tagout program, and it should have every single piece of equipment that requires lockout tagout in your company, as well as the process for implementing that, whatever it is, 6 steps, 8 steps, 25 steps, doesn't matter. It needs to be specific. And as I mentioned before, I'm a big fan of pictures, so if you have pictures to do this, all the better. So that's all we have for the written lockout tagout plan and isolation of hazardous energy today. We're going to keep going with some of these other PowerPoints for April. So hope you have a great day, and see you on the next slide.